The cylinder heads came from Cleveland, the block came from Windsor. The result was an engine that should never have existed, a hybrid that combined the best of two separate Ford architectures into something greater than either parent design could achieve alone. When it screamed past 7,000 revolutions, when it pulled hard from mid-range to redline, when it proved it could outrun Chevrolet's legendary small block, Ford's engineers knew they had created something special. The Boss 302 engine wasn't a destroked big block. It wasn't a bored-out small block. It was a purpose-built racing motor that happened to be street-legal, a combination of advanced metallurgy, radical valve angles, and breathing capacity that pushed American V8 design into territory domestic manufacturers rarely explored. For 2 years, from 1969 through 1970, this engine represented Ford's most sophisticated small displacement performance technology. Then Ford abandoned it, not gradually, not through evolution into something better. Ford simply stopped building the Boss 302 and returned to conventional small block architecture. The Cleveland heads that made the engine special were reassigned to different platforms. The hybrid concept was shelved. By 1971, the specific combination of components that created the Boss 302 powerplant had vanished from Ford's production catalog. What makes an engine manufacturer walk away from a design that works? The Boss 302 wasn't failing. It was winning Trans Am championships. It was earning respect from professional engine builders. It was demonstrating that American engineers could build high-revving, efficient small blocks that challenged European conventions about displacement and power delivery. The answer involves manufacturing economics, corporate consolidation, and the collision between racing-driven engineering and production line reality. It's about the cost of maintaining two separate cylinder head designs, the complexity of hybrid architecture, and decisions made in boardrooms far from dynamometer cells. It's about an engine that succeeded on its own terms but couldn't survive the corporate environment that created it. This is the story of innovation, ambition, and the engine that defied its time. Picture Ford's engine development landscape in 1967. The company operated multiple engine families built at different facilities. The Windsor plant in Ontario produced Ford's workhorse small block V8, the 289 and 302 cubic inch engines that powered everything from Mustangs to pickup trucks. These engines were reliable, affordable to manufacture, and perfectly adequate for their intended applications. They were not, however, designed for high-performance racing. Meanwhile, at the Cleveland Foundry in Ohio, Ford's engineers were developing an entirely new small block architecture. The Cleveland engine, scheduled to debut in 1970 as the 351C, featured advanced design elements borrowed from Ford's 385 series big blocks. The EB cylinder heads incorporated canted valves, larger ports, and combustion chamber geometry that promoted better breathing than anything Windsor was producing. Cleveland represented the future of Ford's small block development, but in 1968, Ford faced an immediate problem. The Sports Car Club of America's Trans Am series limited engine displacement to 5 liters, roughly 305 cubic inches. Chevrolet had responded by destroying their 327 to create the Z28's 302, an engine specifically engineered to dominate road racing within those displacement restrictions. Ford had a 302 already in production at Windsor, but that motor made pedestrian power. It breathed through restrictive cylinder heads designed for economy and durability, not racing. The conventional solution would have been redesigning Windsor's cylinder heads specifically for the Boss application, but development time was limited and Bunky Knudsen demanded a racing competitive engine for the 1969 season. Ford's engineers needed something immediately available that could transform the Windsor 302 into a legitimate high-performance power plant. Someone looked at the Cleveland heads still in development and asked a simple question. Would they physically bolt onto a Windsor block? The two engine families weren't designed for interchangeability. They used different architecture, different manufacturing processes, different design philosophies. Cleveland heads on Windsor blocks violated the normal boundaries of Ford's modular engine strategy, but the basic deck dimensions were surprisingly similar. The bolt patterns aligned. The port locations matched closely enough that intake manifolds could be adapted. What emerged from those initial fit checks was a realization that Ford could create a hybrid engine, combining Cleveland's advanced breathing capacity with Windsor's proven bottom-end durability. They could build something neither foundry could produce independently. Matt Donner's engineering team began specifying components. The Windsor block would provide the foundation with its production-proven main-bearing structure and established manufacturing processes. The Cleveland heads would come from pre-production tooling, casting designs intended for the upcoming 351C, but sized for the 302's smaller bore. The combination would create an engine unlike anything else in Ford's lineup. Corporate approval came with one critical condition. This would be a limited production motor. The hybrid architecture was expensive to assemble. It required unique intake manifolds, special head gaskets, and careful quality control during assembly. Ford would build enough Boss 302 engines to satisfy Trans Am homologation requirements and supply dealer demand, but this wouldn't become a volume power plant. They were building an engine with an expiration date built into its conception. The genius of the Boss 302 engine lived in its cylinder heads. Cleveland's casting engineers had designed these heads around canted valves, a configuration where intake and valves weren't perpendicular to the deck surface, but angled inward at 11 degrees. This canting served multiple purposes. It allowed larger valves to fit within the bore diameter. It created straighter intake and exhaust ports with less directional change. It positioned the valves in the combustion chamber where flame travel could be optimized. The intake valves measured 2.23 inches in diameter. For perspective, the standard Windsor 302 used 1.84-inch intake valves. That half-inch difference translated directly into airflow capacity. Larger valves meant more mixture could enter the cylinder during the intake stroke. More mixture meant more potential power. The exhaust valves were similarly oversized at 1.71 inches, ensuring combustion gases could exit as efficiently as they entered. Port volume and shape mattered as much as valve size. Cleveland's engineers had designed the intake ports with minimal turns and consistent cross-sectional area. Air moving through these ports encountered less turbulence and restriction than in conventional Windsor heads. According to flow bench testing, the Cleveland heads moved approximately 40% more air at typical valve lifts compared to standard Windsor castings. That improvement represented fundamental physics, not tuning tricks. The combustion chambers were open-chamber designs with quench areas that promoted controlled burn rates. Spark plugs positioned centrally ensured even flame propagation. Chamber volume was carefully controlled to maintain compression ratios around 10.51, high enough for performance but compatible with premium pump gasoline available in 1969. But cylinder heads alone don't make an engine. Ford's engineers specified a camshaft with mechanical lifters, a design choice that required periodic valve adjustments but eliminated the RPM limitations of hydraulic systems. The cam profile featured aggressive duration and lift, designed to make power from 3,500 RPM through 6,500 RPM. Below 3,040 RPM, the engine was civilized but not particularly impressive. Above 3,500, it transformed. The bottom end came from Windsor's proven architecture. The block was reinforced with 4-bolt main-bearing caps on the center 3 mains, providing rigidity under high RPM stress. The crankshaft was forged steel balanced for reduced vibration. Connecting rods were heavy-duty forgings stronger than standard Windsor components but similar in design. Pistons were forged aluminum with valve reliefs to accommodate the large Cleveland valves. A Holley 4-barrel carburetor fed the engine through an aluminum intake manifold specifically designed for the Cleveland head ports. The manifold's runners matched the head ports in both size and entry angle, maintaining airflow velocity from carburetor to cylinder. Exhaust manifolds were cast iron on production engines, though racers immediately replaced them with tubular headers that reduced back pressure. Ford rated the engine at 290 horsepower at 5,800 RPM. That number was almost certainly conservative. Independent dyno tests suggested output closer to 320 horsepower, with torque curves that remained flat from 4,500 RPM to redline. The engine didn't make muscle car torque at low RPM, but its power delivery was linear, predictable, and sustained to unusually high engine speeds for a domestic small block. The hybrid nature created unique assembly requirements. Cleveland heads required different head gaskets than standard Windsor applications. The intake manifold didn't interchange with other Ford engines. Valve covers were unique. Pushrod lengths were specific to this combination. Every Boss 302 engine required component selection and assembly processes that didn't align with Ford's standard production methods. Could this complex hybrid architecture survive in mass production? The problems began not on the track but in the accounting department. Every Boss 302 engine required components from 2 separate manufacturing facilities. Cleveland cast the cylinder heads. Windsor machined the blocks. Final assembly happened at yet another location, where specialized workers familiar with the hybrid architecture could ensure proper clearances and specifications. This multi-site production violated Ford's emerging strategy of manufacturing consolidation. By late 1969, Ford's executive leadership was pushing hard for rationalization across all product lines. The company maintained too many engine families with overlapping displacements and capabilities. The Windsor small blocks, Cleveland small blocks, FE big blocks, and 385 series big blocks represented massive duplication of engineering resources and manufacturing infrastructure. Corporate planners wanted fewer engine families, each serving broader market segments. The Boss 302 hybrid didn't fit this rationalization strategy. It was expensive to build, requiring unique components that couldn't be shared with other applications. Production volumes were low, making it difficult to amortize tooling costs. Most critically, it represented backward integration, combining parts from an established architecture with components from a replacement architecture still ramping up production. Lee Iacocca, who assumed increased authority after Bunky Knudson's September 1969 dismissal, viewed engine proliferation as symptomatic of Ford's broader inefficiency problems. The company needed to streamline, standardize, and reduce complexity. Special-purpose racing engines built in limited quantities didn't serve volume-oriented business models. They consumed engineering resources that could be applied to emissions compliance, fuel economy improvements, and corporate average fuel economy regulations looming on the horizon. Then came the insurance crisis. By 1970, underwriters were charging prohibitive premiums on high-performance vehicles. Young buyers couldn't afford coverage, dealers stopped stocking performance models because they couldn't move inventory. The muscle car market that had justified racing homologation engines was collapsing rapidly. Ford's market research indicated the performance segment would shrink dramatically through the early 1970s. Racing itself was becoming politically complicated. Ford's official position remained that the company didn't support factory racing, yet Boss 302 engines were clearly receiving special development attention. Parts flowed to favored teams. Engineers consulted on tuning. The pretense of private racing was transparent fiction. As federal regulators increased scrutiny of automotive safety and emissions, Ford's management became nervous about any appearance of prioritizing racing over responsible engineering. The Cleveland engine family's production debut in 1970 created additional complications. The 351 Cleveland was designed to replace Windsor engines in performance applications. It used the same advanced cylinder heads as the Boss 302, but on a proper Cleveland block with larger displacement. From a product planning perspective, the 351C could serve Boss 302 customers with less manufacturing complexity. Why maintain a hybrid engine when a purpose-built Cleveland could deliver similar performance? Engineers who had developed the Boss 302 pushed back hard. The hybrid wasn't just about horsepower numbers. The combination of Windsor's compact external dimensions with Cleveland's breathing capacity created packaging advantages. The 302's lighter reciprocating mass allowed higher RPM operation than the 351. The engine's character was unique, its power delivery distinct from both pure Windsor and pure Cleveland powerplants. But character doesn't show up on profit-loss statements. By mid-1970, Ford's production planners were forecasting the Boss 302's termination. The decision wasn't unanimous. Racing people argued for continuation. Marketing people recognized the brand equity. But the broader corporate momentum toward standardization and away from performance niches was irreversible. The question was no longer whether Ford would abandon the Boss 302 engine. The question was when. August 1970 brought the official announcement. The Boss 302 engine would not continue for 1971. Ford cited changing market conditions and corporate restructuring. The statement was brief and procedural, acknowledging the engine's racing success while making clear that success alone didn't justify continued production of specialty power plants. The final Boss 302 engines rolled off assembly lines in late summer 1970. Total production across both model years was approximately 8,600 units, almost all installed in Mustangs. A handful went to Mercury Cougars. None were sold as crate motors. None appeared in other Ford products. The engine existed solely for Trans Am homologation, and the street cars required to satisfy production minimums. For engineers who had spent 2 years perfecting the hybrid architecture, the termination felt premature. By 1970, they had resolved early issues with cylinder head sealing, refined intake manifold runner design, and optimized cam timing for street drivability. The engine was becoming what they had envisioned, a legitimate high-performance small block that combined European rev characteristics with American durability. Abandoning development just as refinements were yielding measurable improvements seemed wasteful. Ford's racing partners faced more immediate problems. Teams running Boss 302 engines in Trans Am competition suddenly faced an uncertain parts supply. Would Ford continue supporting racing programs with a discontinued engine? Would Cleveland heads remain available for rebuilds? Would special components like forged pistons and heavy-duty connecting rods still be manufactured? The answers were vague and uncomfortable. According to period interviews, many race teams immediately began stockpiling parts, buying surplus inventory from Ford before supplies disappeared. Engine builders purchased multiple sets of Cleveland heads. Teams ordered complete short block assemblies. The rush to secure components before production ceased created a brief spike in Boss 302 parts demand, ironically demonstrating market interest precisely as Ford was exiting. On the street, Boss 302 owners faced different concerns. The engine's hybrid architecture meant routine service required knowledge of both Windsor and Cleveland specifications. Mechanics unfamiliar with the combination sometimes installed incorrect components. Valve adjustments, necessary with mechanical lifters, required understanding of the specific Cleveland head geometry. As years passed and original Boss 302s aged, finding qualified technicians became increasingly difficult. Ford directed performance customers toward the 351 Cleveland, which officially replaced the Boss 302 in Mustang applications. The 351C used the same basic cylinder head design but with proper Cleveland architecture throughout. It made competitive power, it was easier to service, and it didn't require hybrid manufacturing processes. From an engineering standpoint, it was the logical successor, but the 351C wasn't the same. The additional displacement changed power delivery characteristics. The larger external dimensions affected packaging and weight distribution. The Cleveland architecture, while advanced, lacked Windsor's decades of production refinement. Early 351C engines suffered quality issues that the mature Boss 302 had largely resolved. Performance enthusiasts who had experienced the Boss 302's linear power delivery and willingness to rev noticed the differences immediately. Magazine tests reflected this. While the 351C was faster in straight lines, testers consistently noted that the Boss 302 felt sharper, more responsive, more willing to sustain high RPM. The hybrid engine had developed character through its combination of components, character that pure Cleveland architecture didn't quite replicate. By 1971, the tooling for Boss 302 cylinder heads was in storage. The unique intake manifolds were discontinued. The special assembly procedures were documented and filed. Ford had moved on, redirecting engineering resources toward emissions compliance, catalytic converter development, and the corporate challenges of building cars in a post-muscle car regulatory environment. The Boss 302 engine became a footnote, mentioned briefly in Ford literature as a limited production racing power plant. Its 2-year production run seemed destined for obscurity, overshadowed by longer-lived Ford performance engines and forgotten in the broader collapse of the performance market. What Ford didn't anticipate was how engine builders would remember the Boss 302. As the performance aftermarket matured through the 1980s and 1990s, professional builders began recognizing what Ford had briefly achieved. The Cleveland heads on Windsor block combination represented a solution to fundamental small block Ford limitations, and that solution remained viable decades after production ceased. The Cleveland heads, even in their original Boss 302 configuration, flowed better than any Windsor casting Ford ever produced. Engine builders working with Windsor blocks discovered they could adapt Cleveland heads with appropriate machine work, essentially recreating Ford's 1969 hybrid architecture. A cottage industry emerged around Cleveland head conversions, with specialized intake manifolds, head gaskets, and mounting hardware making the swap practical. Modern engine builders often cite the Boss 302 as proof that cylinder head design matters more than displacement for high RPM power. The engine made approximately 1.04 horsepower per cubic inch, exceptional for a production American V8 in 1969. That specific output came almost entirely from breathing capacity, from the ability to move air efficiently through combustion chambers at high flow rates. The lesson wasn't lost on professional engine builders or serious enthusiasts. Collector value reflected this technical respect. Original Boss 302 engines, still in their factory configuration, became valuable cores. Engine builders would pay premium prices for unmolested Boss motors, not to restore but to study and measure. The original Cleveland castings, with their specific port configurations and chamber volumes, served as templates for modern reproductions and CNC-ported aftermarket heads. Ford's own engineers looked back at the Boss 302 when developing modern Coyote modular engines for Mustang applications. The Coyote philosophy, high revving, sophisticated valve train, emphasis on breathing over displacement, traces intellectual lineage to the Boss 302 concept. Ford's modern small blocks are technologically advanced, but the strategic approach, building motors that make power through efficiency rather than brute displacement, echoes decisions made in 1968. The aftermarket preserved the Boss 302's genetic material. Companies like Edelbrock and Trickflow developed Cleveland-style heads for Windsor blocks, essentially productizing the hybrid concept Ford abandoned. These modern heads use contemporary materials and manufacturing techniques, but follow the original Boss 302 precedent, combining Cleveland's breathing advantages with Windsor's established bottom-end architecture. Racing organizations continued using Boss 302 engines long after Ford discontinued production. Vintage Trans Am racing, which emerged as an organized motorsport category in the 1990s, featured numerous Boss-powered Mustangs. Engine builders had stockpiled parts and developed rebuild procedures that allowed these engines to remain competitive decades after their factory production ended. The racing success that justified the engine's creation extended far beyond Ford's involvement. Technical publications analyzed the Boss 302 as a case study in hybrid architecture benefits and manufacturing challenges. Engineering papers discussed the canted valve design, port flow characteristics, and combustion chamber efficiency. What Ford viewed as an expensive special production motor, academic engineers recognized as an unusually sophisticated small block design that pushed American V8 development in productive directions. Perhaps most significantly, the Boss 302 demonstrated that Ford could build engines matching European sophistication when circumstances demanded it. The American automotive industry had a reputation for prioritizing torque over revs, displacement over efficiency. The Boss 302 contradicted that stereotype. It was an American engine that revved like a European motor, that made power through airflow rather than cubic inches, that required skill to extract maximum performance. It proved domestic manufacturers could engineer high-performance motors that didn't rely solely on displacement advantages. The tragedy was that Ford didn't pursue this direction. Instead of building on the Boss 302's technical foundation, Ford retreated to conventional small block development. The Cleveland family eventually withered, replaced by Windsor-derived engines with updated emission controls but conservative performance design. The brief moment when Ford prioritized advanced cylinder head architecture and high RPM capability closed, not to reopen. For decades, the cylinder heads came from Cleveland, the block came from Windsor. For 2 years, that combination produced one of the most sophisticated small displacement V8s ever installed in an American production car. Then Ford walked away. Not because the engine failed, but because maintaining hybrid architecture didn't align with corporate standardization priorities. The Boss 302 engine story illustrates the tension between engineering excellence and manufacturing pragmatism. The engineers who created it understood they were building something special, an engine that combined the best elements of two separate architectures. The corporate executives who terminated it understood they were managing a business, not a racing team. Both perspectives were valid. Both shaped the outcome. What makes the abandonment poignant is recognizing what was lost. Ford spent decades developing Windsor small blocks without ever matching the Boss 302's breathing efficiency. The Cleveland family's advanced cylinder head design languished in applications that didn't exploit its capabilities. The hybrid concept, which solved real technical limitations, was never fully explored. Ford had created an answer to a question they decided to stop asking. Today, the Boss 302 engine represents a path not taken, a glimpse of what American V8 development could have prioritized if circumstances had been different. It demonstrated that domestic engineers could build sophisticated small blocks when motivated by racing requirements and unencumbered by cost constraints. It proved that thoughtful hybrid architecture could yield performance advantages neither parent design achieved independently. The engines that survived remain mechanical artifacts from a brief period when Ford's racing ambitions overrode manufacturing conservatism. They run, they rev, they make power in ways that still impress professional engine builders familiar with Ford's small block capabilities. They represent engineering decisions made for performance rather than cost, and they carry that priority in every component. If you've built a Boss 302 engine, if you've experienced that combination of Cleveland heads and Windsor block, if you've heard one sing past 6,000 revolutions, share your story in the comments. Let's remember what Ford created before corporate priorities changed. Thanks for watching, and I'll see you in the next video.